Hi guys, welcome to our first online lesson. Now, the last thing we talked about was parallel and perpendicular lines. Alright, and you probably remember parallel lines being lines that have the same gradient. And basically what they looked like was side by side, there were lines that would never touch, depending on how, even if they extended across the page. What we also talked were perpendicular lines, which were lines that had gradient that multiplied to equal -1. Okay, and what happened with those gradients was that when we drew the lines, they would meet at right angles. Okay, so far we just looked at those two, but today we're going to look at two lines that aren't parallel or perpendicular. So what I've got on the other side here is some graphing paper, and what we're going to do is we're going to draw the lines y equals 2x minus 8, alright? We're going to do that in black, and then we're going to do the line y equals minus 2x plus 4, okay? Now, when we're drawing these lines, basically what we need to know is we already know our special formula, which is y equals mx plus b. And we can have our lines in a different form, but at the moment we've got them in y equals mx plus b form. So we know this line over here, alright, our gradient is -2, and our b is 4, our y-intercept is 4, alright? And over here, our gradient is 2, and our y-intercept is -8, okay? Alright, let me just fix this light. Okay, so when we have these two lines, basically we can use the y-intercept and the gradient to start plotting the rest of the line. So -8 and 0 is going to be there, alright? Okay, so that's basically where our y-intercept is. And our gradient of 2 means every time it goes across by 1, it goes up by 2, across by 1, up by 2, across by 1, up by 2. And we can use a ruler to sketch out the rest of these points. Right? And we're just going to label the point y equals 2x minus 8. Now, before we continue, we're just going to look at these gradients, right? Obviously, they aren't equal, and 2 times -2 equals -4 and not -1, so they're neither parallel or perpendicular. So what we're going to do is then change color and sketch out this line here. So y-intercept of 4 means it's the 0, 4 point over there. Gradient of -2 means it goes across by 1, down by 2, across by 1, down by 2, until it meets right at this point there. And so we've got the line y equals -2x plus 4, and also y equals 2x minus 8, which we can see meets at the point 3, -2, where x is 3 and y equals -2. Now, the thing about this point is we don't actually need to draw the whole graph to find that point. One thing we can do instead is use algebra and a way of solving simultaneous equations to find this point as well. So what we're going to do is we're going to write our two equations in first. I'm going to show you how those 2 points actually fit, by substituting those 2 points in there, right? Remember we said the point was, I believe, 3 and -2, right? Where x was 3 and y was -2. And what we're going to do is we're going to look at these two equations and see why that's true, all right? So if x can be replaced with 3 and y can be replaced with -2, then we're basically saying 2 times 3 minus 8 is -2. We know that 2 times 3 is 6, and 6 minus 8 does equal -2. So we're happy with that, all right? And so that's one way of showing that our equation works just for this equation here. Now we're going to do the same with the other equation. -2 equals -2 times 3 plus 4. We also know -2 times 3 is -6 plus 4, and that all equals to -2 as well. So we are happy on this side as well. Okay, so what we've just done is we've substituted this point to find that this point fits into both those equations. However, if I ask you to just find this point from these two equations, it's actually quite difficult. And there is a method called the substitution method, which helps us find these 2 points a lot easier. So what we're going to do is we're going to start off with our equations again. Y equals 2x minus 8, and y equals minus 2x plus 4. But this time we're going to label the equations equation 1 and equation 2. Now, with our substitution method, what we are trying to find is a way to substitute one of the letters out. Now, can we see above how x and y were both equal for both equations here? That means that this y should be equal to this y, and everything that that y was equal to can also be substituted by this y here. So what I'm going to write below is our normal first step when we're solving simultaneous equations. We are substituting equation 1 into equation 2. Now what that basically means is we have a look here that y equals 2x minus 8. We're going to replace every y in equation 2 with 2x minus 8. So what that will look like is we would end up writing 2x minus 8 equals minus 2x plus 4. Now, if we're just looking at equation 2, right, we started off with y equals minus 2x plus 4. And what we've just done is we've substituted the y from equation 1 into the y in equation 2. Now, what we've got is, you'll notice that we no longer have any y values, and we can actually then just solve this equation. One way of solving this equation is by moving this 2x to the other side by adding 2x. Alright, so at this stage there are many different ways of solving an equation. As long as you get the same answer as me, which should be x equals to 3, it doesn't matter really how you're solving this equation. Okay, and then we're going to plus 8 to both sides. So 4 plus 8 is 12. And then last but not least, we're going to divide by 4, and x equals to 3. Which, if you remember before, that's what it equaled to up here. So far we've found one of the points, alright? Now, this is the easy step because we already have an answer. It's similar to our step when we had to find the b and y equals mx plus b, but this time we're just substituting in x. So sub x equals 3 into any equation. Now we can choose equation 1 or equation 2, just because I know that 1 will be a little bit easier. We're going to write equation 1 out like that. Okay, so we know that x is 3, so we're going to replace the x with 3. And then again, hopefully you know 2 times 3 is 6, minus 8 is -2. So what we've just done is found our values. X is 3 and y equals -2. And this is just what we've done all algebraically. Okay, so that's one example. We'll do another example just to make sure you understand the gist of things. This time our equations are going to look slightly different. Okay, so I'm going to write an equation 2x plus 3y equals 11. We're going to call this equation 1. And then equation 2, I'm going to say x equals 7y minus 3. Now, in our previous example, you'll notice we had two y equals and y equals, and it was quite easy to substitute this and replace the whole y. And in this case, we don't really have that luxury because we've got a 2x, we've got an x, we've got a 3y and a 7y, and like none of the numbers are the same at the moment. It's actually quite easy to make one of the numbers the same. You'll notice we have an x equals a bunch of stuff. So what we're going to do first is to actually just double our equation. Now, if you remember, equations are a set of scales. So if we double one side, we actually need to double everything on the other side. So the 7y is going to turn into 14y, the 3 is going to turn into a 6, and we're going to have 2x equals 17y minus 6. Actually, that's not double of 17, it's 14. Yep. Now, what we'll do next is, again, we now notice that we've got a 2x over here, we've got a 2x over here, and by replacing the whole 2x, we can actually substitute out the 2x. So that's what I'm going to do here again. I'm going to this time sub equation 2 into equation 1. Now what that will look like is we get equation 1, which used to be 2x, but now is 14y minus 6. We're going to add 3y to that, and that is going to all equal to 11. Now we've got 14y minus 6 plus 3y equals 11. Now the whole point of substituting is to completely get rid of one of the letters. Do we notice that x is now missing? That's because we've substituted it out. So what we're going to do next is solve this equation. So we know 14 plus 3y is going to equal to 17y. That's going to minus 6 and equal to 11. And then we're just going to solve this equation like we did before. So we're going to plus 6 to both sides. 17y equals 17. And then we're going to divide 17. Y equals to 1. Now, notice how we didn't draw any of the graphs and we've already gotten one of the letters. What we need to do to find the other letter is to finish solving this equation. So we're going to sub y equals to 1 into any of these two equations. Maybe I'll substitute it into equation 2 this time. So now I have x equals 7 times 1 minus 3. We know that 7 times 1 is 7, minus 3 equals 4. So we end up with x equals 4. So what we've just done is we know if we substitute this into this equation over here, that's true, right? That's kind of the whole point of this step down here. But what we can also do is substitute this back into our first equation just to double check, right? So 2 times 4 plus 3 times 1, whoops, equals 11. Does 8 plus 3 equal to 11? That means x equals 4 and y equals 1 is the only solution, only pair of numbers that works for these two equations.